are working with robot models or robot system design, you need to have the CAD models of your robot or the robots that you are working with. With most manufacturers, for example, KUKA or Universal Robot or Mitsubishi, so all these companies provide CAD information or CAD data of their robots at their website. So you can go to their website and download robots that you want to work with. Sometimes the CAD models will already have the kinematic information into them, or maybe they will not have the kinematic information. And in that case, you will need to define all the joints by yourself. And the cool thing is that in Process Simulate, once you have developed the simulation, you can connect your real UR robot with Process Simulate. So you can transfer the program directly from Process Simulate. So now it has imported this robot into the simulation, and yeah, if you right click it, you will see that. Okay. It is not connected. So when you are importing CAD data, you may face different challenges that I had already used this one, so maybe I'll use the other one. If it is not connected, then you need to spend time and connect it to any component that is not connected to the rest of the robot, and then you will go to its kinematic information and will connect it there. But since I don't have time for that, but I will show you how you can do it. So if I select this robot, for example, and I go to kinematic editor, I can see all its joints or elements that are connected to each other. Similarly, for other robot, I can see its kinematic editor, how they are connected, and you can see that all these elements, they have different colors, and you can see that which element is it. So blue is this one, green is where is this green? So maybe it is hidden somewhere in besides this. But you can see that this section, this is not defined in its kinematic editor. So you will also define it in the kinematic editor, and then it will also start moving. But for now, I am deleting this one, and I will use this robot. And if I go for this kinematic editor, I can see how these different elements are connected with each other. I can also see, and you can also see this information here. Tool post, tool frame. Okay, now we want to, for example, import some more information, maybe some other component, maybe a conveyor. And to import a conveyor into Process Simulate, how we do it is, I have opened this annex as well. In the annex software, you will open whatever information you want to import. So here I have placed these CAD models. So if you try to open it in Process Simulate, it will not import into Process Simulate. Maybe in some instances it may do it, but you may lose some information. So, and also I would like to mention that there can be different ways of importing this CAD geometry into Process Simulate. And maybe different people are working with different strategies, but the strategy that I have been using or I have been working with, where you will find or you will have the least challenges during your project is this one, that for example, now I want to import the conveyor into process simulate. How you will do it, that you will create a new resource, and you will select the resource type. Process simulate is intelligent in this way that it knows what resource you are selecting, and then it will take it as that resource. So if you if you define it as a robot and want to use it as a conveyor, maybe the geometry looks like as a conveyor, but you will have problems to use it as a conveyor. So you need to define the right or the most appropriate component type or a resource type. So now I'm using a conveyor. Okay. So once you have created a resource, which is a conveyor in this case, you can rename it as well. You don't necessarily need to use it as a conveyor. So you can do the renaming after you have created it. For now, I will just use it as conveyor and then end modeling. After you end modeling, then save it into your somewhere in your root folder. I am saving it here. Save. So once you have saved it, then you go to annex. Then you go to export and export as JT. As I said, that JT is the native format for process simulate. And then you need to define that where you want to export this file. And I am defining it that I want to place it the same file that I have created for process simulate. So I created this conveyor code JT, and I will replace this file that process simulate had created. So, and it will ask me that do you want to replace it? And I say yes. Then if you want to save it as assembly and folders as a single file, so there are different types. Basically, I don't need assembly for this component type, and I will save it as a single file. Maybe assemblies only, and then okay. Once you do this, it has replaced the file that process simulate had created. And now if you don't see it, but if you select this conveyor and then again do it as set it as set modeling scope, and you will see this conveyor that you have exported from annex. Then you need to place it at the right position. And how you do it, you use this placement manipulator for this purpose. And by using placement manipulator, you can reorient the object. You can define here this. So with this button, I have just displayed the floor. So if you do this, then you don't see the floor. Now you see the floor. You can redefine the floor as well. Okay, so now you have this conveyor as well in the simulation. And then you need to define, for example, or you need to import a gripper. I will do the same thing again. You will go to modeling, create new resource. I need to define it as a gripper. If I define it, for example, some other thing, clamp or gun or anything else, it is this welding gun. So I need to define it as a gripper. So, okay, now a gripper has been created. I end modeling. It will ask me to where to save it, and I tell it that here I have gripper and yes, process simulate, and here I save the gripper. Then I go to annex, and in annex I open the CAD model in annex, and I have created a very simple gripper just to show how gripper works. So you will find very sophisticated grippers online. So gripper, this is the file that I created from process simulate. I replaced this file, yes. And now I need assemblies and folder of parts, and both I need information for both parts and assemblies. Apply. I don't see the file in process simulate, but while gripper is selected, or I selected and then I set modeling scope. And now you see that the gripper has been imported. How to move it? Right click it and use this placement manipulator. Okay, then we need to define how this gripper works, because we found the robot, we were lucky and we found the robot from KUKA website, for example, the robot that we wanted to use. But there may be cases when you have your own robotic arm, or maybe you don't find a CAD model of your robot from online. Then you might need to create the CAD model of the robot yourself. And in that case, it will not have any information. For example, now if I select this gripper, I go to kinematic editor, there is no information that how the fingers move or how this gripper works, and you have to do it by yourself. So this is an important thing to understand how you do it. So I select the gripper, I go to kinematic editor, and first I need to define all the elements that this gripper has. So I create first link, and it will ask me to define that what is there in the first link. This is a very simple gripper, and in this case there is only one object here. There can be more than one object that you want to define for the link one. You will understand this thing in a while. Then I go to link 2. Here I select this finger, but there are also these rubber pads which also should move when the finger is moving. So I will select all these pads as well. So this is the second link. Then I need to define the other finger. And in this case, there are these objects that should move all together. So now I have these 3 objects in my gripper. As I said, there can be very complex grippers, but this is a very simple gripper. So now I need to define how this gripper works. How I do it, for example, this object and this object, I want this finger to move in this direction. So I will create a finger like this. So just click on this element and then connect it with the other link, and this window will appear. And you may note that this yellow line is showing that in which direction the finger will move. Now it will move in this direction, but I want it to move in this direction. So I select it this way from this. This is not a revolute joint type, but a prismatic. And then it will ask me limit types. Limit types is that how much it opens in one go. I mean, if you open the gripper, how much this gripper opens. So you can define it as variable or constant. I take it as constant for now, and I take it 50, for example. So this finger is moving up to here. Okay, I'm increasing this limit, not 50 yet. Okay, similarly, I define the connection with the other finger, and okay, now I have both fingers defined. They will move in this direction. It can also be a revolute joint, in which case it will move around an axis. So maybe you may have a gripper which has axial movement around the length. So depending on the gripper design, for now I am using this prismatic joint. But now you can see that each finger is moving independently. But if you want to make it like if you move the gripper, both fingers should move together. For that purpose, you can select any of the joints and then define joint dependency. Now you can see that it is independent, but instead you make it as a joint function as J2. It is dependent on J2 and apply close. And now if I move it, they will move together. Okay. It will be a very good idea to keep saving your file after every few minutes, or because sometimes process simulate can crash. I don't know why, but since I started working with process simulate some years ago, it often happens. And in that case, it is a good idea that you keep saving your file so that you don't lose what you have done in 15 minutes or half an hour. Okay, after this, we still need to define the tool frame of the gripper and the base frame. If you have worked with CAD softwares, any of the CAD softwares, then you can understand these concepts easily. If you have not worked, it may take you some time. So I'm defining the frame that will be connected with the robot. So for now, I have selected this frame, and then it needs to know tool frame. Okay, so now is the time to connect it with the robot. How you connect it with the robot? If you right click it and you select this mount tool option, and if you go to mount tool, it will ask you that which tool do you want to attach to this robot, because in the simulation study maybe you have many grippers placed in a simulation environment, so you need to select that this is the gripper that I want to attach. And yes, how it should get connected, base frame, apply, as I have selected this one. Then I will do some adjustment. The geometric frame is not at the right position, so but it is okay for now. And you want to see if it is connected with the robot or not. If you right click the robot and go to robot jog, and then you can see if it is connected or not. And you can see that it is moving with the robot. Okay, then an important thing is poses for the robot or poses for the gripper. If you click the robot and go to modeling pose editor, you can see that there is only one pose for now. And whenever you will double click on home, it will go to this default position. Whenever you are working with the robots, you will always see that there is a default home position for your component or for your robot. You can define new poses as well. So for now, I am this gripper is too big, actually. For example, now I have defined a new pose. So if I go to home, it will be this. If I go to this is pose 1. You can define as many poses as you may need. Similarly, we can have poses for gripper, for example. Okay, so now we have a robot and a gripper that is ready to perform some task. Okay, when you want to create an object that you want to play with the robot, then it is not a resource. I mean, also in the real world, if a robot is manipulating some objects, resources are these things like conveyor or gripper, or if there is fencing around, all these things, these are resources, maybe a machine. But the components that it picks and places, etc., they are not resources. So in process simulate, you define them differently. And here we define them as create new part. And I don't go into this detail. This is something related to event-based simulation, but just selected part prototype. So now it is the same thing. I end modeling, and here I have created. In process simulate, you can define a conveyor as well. I mean, now I have imported the geometry of the conveyor, but I haven't defined the functionality of a conveyor. If you define it as a conveyor, then when you are running the simulation, anything that you place on top of the conveyor, it will start moving in this direction based on the speed that you have defined in the conveyor parameters. But for now, I will not go into that detail. I will just define its movement manually, that how this component moves. So, okay, now we have this component placed here. Yes, and then, okay, about the interface, I have discussed other things, but I missed a few things. Okay, so this is object tree on the left side of the window. All the objects that you create in process simulator, resources, components, parts, all these things, they appear in this area. All the frames, we haven't created any frames yet, but you can see all these object tree where you can find all the components that have been created. This is object tree, and then there is an operation tree. Yes, operation tree. So far, we haven't created any operation. By operation, I mean the tasks in the simulation. For example, robotic tasks, pick and place tasks. So all these tasks, they appear here in the operations tree. And then we have here this sequence editor. Once you have created some operations, you will see that all these operations will appear here, and you can define the sequence in which sequence those operations should happen. And then there is path editor. In the path editor, you optimize the path of your robot. For example, now it will be very simple pick and place, but then you refine its motions in the path editor. We will do it now. So now we have this object. Whatever object you want to play with, I will show you one thing that probably you should always do. Because once you have used the robot to pick and place the component, it will pick the component from here, it will place it at some other place. But then if you reset the simulation, the object will not return to its default position. And to avoid this situation, what you should do is create a dummy operation. So new object flow operation, just OK, and then copy and paste this. So this is a kind of thing which is not a standard thing with process simulate, but after struggling a lot with process simulate, I defined this technique by myself, that just copy and paste its default position. So whenever you will run this operation, this object will go to its default position. So you can reset it every time. Okay, then we define another flow operation for this, because I want this object to move here. And as a reset. Here you can adjust the speed of the simulation. So I am slowing it down. Okay, so now the object is here. Then I will define an operation for the robot for pick and place. So I go to new pick and place operation. Gripper is this. Okay, it is giving me an error that gripper is not a gripper. So it is strange error, but the thing is that gripper, its name is gripper, but process simulate still needs to know if it is a gripper. So how we do it is suppose tool definition is not appearing. We have a problem. I don't know why tool definition is not appearing. Okay, but you also need to define the gripping entities, which are the entities that actually grip the object. So these are the fingers, but when you run the simulation, if you don't define the entities, or if you define the whole gripper, then even if this component touches the object that need to be picked, it will pick it. But in the real world, it is not the case. So we need to define the gripping entities. In this case, I am defining these pads as gripping entities. Okay, and do not check collision with. So this one, okay. And in that case, I need. Sorry, I need to do it again. Okay, so all these poses you can grab. This is something that you will need to adjust depending on the size of the object that you want to pick, and also the gripper. Okay. I'm creating another resource very quickly, container and okay. You can just randomly select a point, because afterwards you can redefine it. Now we have this box flow simulation, and then I make this operation as set current operation. No reset, and okay. So now I go to path editor. Its frame is not very accurately defined. Okay, when you are defining a pick position, you always have some motions before the picking of the component and after picking of the component. So you need to define. If you have taken, or all of you have taken that training of Universal Robot, you might have seen that there is some motion before picking the object and then after picking the object. So at location before that, how the creeper comes towards the picking location. Okay. Location after. It's not picked. Okay, so it is offering some challenges. I don't know why it is not picking definitions. Okay, then you will define the paths for every motion depending on how on the component that you are working with. Okay, it is often some challenges. I will continue to work on it, and I will upload the video over at Moodle. So basically, that's it. You define all the pick and place paths, and then once you have defined or optimized the path, then you delete it from here, and in the sequence editor you get a more accurate path.